So hey, hi guys. So today we are going to solve GFG's problem of the day. So here the problem they have stated is sorted subsequence of size 3. So you can clearly go through the problem statement. You are given an array. Okay, you need to find three elements such that ARR of I is less than ARR of J is less than ARR of K. So simply they are saying find three elements in a subsequence order such that all three indexes are you know j is greater than I and k is greater than j. So and also they mentioned the note we need to find these elements in a sorted sequence. Okay, so they also given some note, right? We need to take care of this note. I already if you don't be careful enough here, then you might get a wrong submission. So yep, so the output will be 1 if the subsequence returned by the function is present in the array. So simply your job is to find these three elements such that it satisfies this particular condition. Okay, this particular condition. So if you manage to do that, they will give you correct output. If not, they'll give you wrong output. Then you can see what went wrong, all those things. So why don't we just dive in and solve this particular problem. So we'll take the example for 12113 and I'll just show you here. So the given problem is 12113. So we can see here, if I take indexes 0, 1, 2, 3 and 4, you see 1 is less than 2 and 2 is less than 3, and all these three elements have different indices and it is a subsequence. So if you find these elements right, our work is done. So how do we do this? So many of them come up with a brute force approach, saying that when, like, let's just say here 1 2 1 1 3, even I came up with the brute force approach, saying that whenever I'm here, right, this particular element, I will search a smaller element in the left side and a greater element in the right side. Once I find these things, right, I'll put these elements into my answer list, and then I'll return it. So what happens here is, let's just say you're here, you'll search for the smallest element from the left side and greater element on the right side. When you're here, you'll do the same thing. When you're here, you'll do the same thing. So what happens is the time complexity goes to n square. But clearly they have mentioned is you should somehow solve this in a O of n complexity and the space complexity as well. So how to do that? So instead of traversing every time left smaller and right greater, why don't we find for every element left smaller elements and for every element right greater elements? If you do that, what happens is it's in a linear and it will be very easy to identify it. So how to do that? Let's just say we have 1 2 1 1 3. So simply think, we'll just finding smaller elements for all the elements. Okay, if there exists. So for 1, if there exists any smaller element on left side, no, that does not exist, so we put -1. So for 2, if there exists any smaller element, yes, there exists a smaller element which is 1, so we put indexes. Okay, for 2 there exists a smaller element, so for 1, does do we exist any element that is smaller than 1 from the left side? No, does not exist. Same as goes for -1. And for 3, what is the smaller element for 3? The left nearest smaller element, that is 3, meaning this particular index. You can see just the nearest smaller element. And if you go, same thing we do it for greater elements. For 3, if there exists any greater element on the right side, no, it does not exist. For 1, there exists a greater element which is 3, which is index 4, and same goes for 1 4. And for 2 2 itself also. For 2, the greater element is not 1 or 1, it's 3, so 4. But for 1, greater element is what? 2, the nearest greater element, so 1. So you can see here we have all the elements, it's left greater, right greater, and all those things. So if you see, carefully observe here, for 1 there does not exist any left smaller element, but there do exist one greater element on the right side. When you come at 2, there exists a smaller element on the left side, and also there exists a greater element on the right side, which clearly indicates us, yes, this is a subsequence. This itself, the element 2 has something of a pattern like this, and saying at 0th index which is 1, and at 4 index 3. So we got the answer. So if you solve it like this, this will be more optimal. So why don't we just go and implement this strategy. I know you will be asking me question how to implement this -1 and left nearest smaller one and right nearest greater element. So while coding, I'll make sure you understand it even better. So let's just start implementing the method. So what do we have here? So we need to find those elements, right? We need to find those elements. Let's keep it as answer. So I'll be doing this in Java, and it's a very simple code. Instead of list, you can use vector in CPP, and the implementation is the same. It does not vary that much. And let's just take the size of an array. Okay, and now we can clearly see that we need indices, okay, for the smaller and the greater. So we take similar size array, saying that we need a smaller, saying for every element if there exists a left nearest smaller element or something like that, and we take of size n. So similarly we do for greater as well. Okay, we take it this way. So we know how do we need to insert. So first of all, for any element, the starting element, there does not exist a previous nearest smaller element, right? What do you mean by that? I'll tell you. Wait, see, if we here for 1 there does not exist any previous smaller element, that's why we inserted -1, and the same goes for every last element. There does not exist the right nearest greater element, which is -1. So we don't have greater element simply. So why I'm using -1 in sense, it's just indices. -1 in sense there no element exists. So we'll just now build our smaller array first. So we need to traverse from 1. You can ask why 1, because already we inserted at 0 it is -1. So we need not to worry about the first element. We need to worry about the next elements. So 1, we need to traverse all the way through all the elements. So now you can see how we were doing this particular thing. Let's just say we are at 2. Wait, I'll tell you. 1 2 1 1 3. Let's just say you are at 2. If at all, if the current element itself is smaller, okay, wait, let's just keep track of the nearest. How to keep track of the nearest smaller element? We need an index, right? initially we just believe that initially we'll just believe that okay, the first element itself the smaller. If not, we'll just keep on updating it. And what I'm saying is, if at all current element, okay, current element what we are here, if at all if it was smaller than our minimum index, meaning that if at all the current element itself is smaller, then there does not exist any smaller element for that particular current element. And also we have found, okay, we have found our new minimum index itself is a new minimum index. At the same time, you need to update that at that particular index, if current element itself is the smaller than the previous, previous minimum index, that means there does not exist any particular element for this particular element which is smaller element. So we need to insert it as -1. I mean, saying clearly indicating that there does not exist element, smaller element for that particular element. Or else okay, there exist, okay, that element itself is greater, which means there exists an element which is smaller. And where do we have that smaller element? In min index. That's what we keep on updating our min index whenever we find the minimum element at that particular point. So same thing, now we'll just build our greater array. So for this, again we need max index, keeping track of the nearest, right greater element. So max index is, we initially believe that it is itself the last element, okay, and we know we need to traverse from the last second element, because we already know that for the last element there does not exist any greater element on the right side. So here we go, if you take n-2 and we go all the way along till the last element, okay. So how do we know? See, if at all current element, we are finding the greater element, right? If at all the current element is greater, right? If at all the current element itself is greater than our max index, then that clearly indicates that there is no element which is greater than current element. And also we found our new max element as well. Update it with our current I. At the same time, there does not exist any greater element on the right side for that particular element, clearly indicating we are doing with -1. Or else, yes, the current element was actually smaller element, that means we have already the greater element because we are traversing from the left side, right? So it says that we actually have a greater element on the right side for this particular element at max index. So once we build this array, right, we actually build the similar array here. Now what we need to do, we need to compare and check for every particular element if there exists one smaller, if there exists a smaller element and the greater element at the same time. If it exists, we just put these elements and we return the answer. That's as simple as it can get. So let's just traverse all the elements now and check if for any element, if there exists a smaller on the left side or the right side. So we traverse all the elements now. So we traverse all the elements, we just check, okay, if for that particular element, right, that particular element, for that particular element, there it exists one smaller element, which means not -1. If it is -1, we don't have any element on the left side of the smaller element. At the same time, we also check we also check so we also check at I for greater element, if there exists any greater element. If there exists any greater element which is not -1, then it clearly indicates that for that particular element it follows the given pattern which they said 1 is less than 2 is less than 3, which we already discussed in the problem statement. So what we need to do, we need to add the answer, right? We need to add, and also all the way along we're just storing the indices for that particular element. So we are storing the indices, saying that I'll explain you it. So what were we actually doing? In the smaller part, we were storing the indices, actual indices. What resides at 0, 1. What resides at 4, 3. Right. So we need to add the elements. We need to see clearly it says find the three numbers. So since both does not have -1, clearly indicating there exists element and we stored its index, so we can directly access its index in our AR array. And this goes the smaller element and the current element itself. For that element only we are searching, the AR of I only we are searching, right? It's left and it's right greater, so itself, the element itself. And then we also say that we add the greater element for this particular index as well, which is I. So yep, this is done. We can just no need to do further checks and further elements. Once we find any one subsequence of satisfying an element with this pattern, we can just return our answer. No need to further keep on going. So this will help us updating if there exist any kind of subsequence. If not, we didn't find any subsequence, then we just return. They clearly said if you don't find any subsequence, just clearly return the empty list, which is ans. So we'll just run this particular thing and see if anything went wrong, something like that. Okay. Oh, I forgot to mention equals. This happens in phone, doesn't usually happen in laptop, and there is no charge in laptop, so I had to do this way. Okay, spell mistakes, my god, it's not okay. I will just debug whatever the mistakes are there and then we'll further proceed. So okay, you can see we have expected output. We'll just submit and see if it works fine. It's not about doing it in phone or doing it in laptop. It's just getting the correct answer and getting the correct intuition. So yep, I actually solved this problem before, but then for that I used actually stock, but I was getting time complexity, but somehow I managed. But this was more optimal way to solve this particular problem. And the problem is very easy. I don't know why they put kind of medium. Yep, medium. So see why the accuracy is very low, because most of them they'll forget this particular point. You need to update, you need to find all three elements only if and only if it satisfies this particular condition. If not, you just need to return empty array. And if you don't take care of the particular indexes left nearest smaller and right nearest greater element, you'll get a wrong answer. So because of that only, I think they're getting very low accuracy or something. Yep, I hope you understood the problem and the approach and the implementation as well. So yeah, I'll keep on solving the problems. See you guys next time.